Okay, we're looking at TMUA 2016, paper 2, and this is going to be a look at question 8, which talks about statements and whether they are true or not. And we need to decide which, if any, are the correct statements. So it talks about region. It talks about a region. A region is defined by some inequalities, and which of these statements are true for every point in that region. So let's try and draw the region out first. So I'm going to rewrite these inequalities. We've got y is greater than minus x plus 6, and y, taking that over that side, so changing the sign, y is less than x plus 4. Those are our two inequalities. So let's draw those. So we've got our axes. We've got two straight lines. One of them is positive and goes through the y-axis at 6. I say positive. That's the one with the -1 gradient. And the other one has a positive gradient and goes through at 4. So that's here, say, and that's perpendicular. So it's like that. It's worth working out where they intersect, I think. So how do we work that out? If we add these together, we get 2y is 10, so it's 5, and that must give us y is 5. This must give us x is 1. So I'm saying that that point there is 1, 5, the point of intersection. And then we can start thinking about these. So now we've drawn our, let's be clear about the region. Y is bigger than minus x plus 6. So it's bigger than this line. So it's to the right of that line. And it's less than x plus 4. So it's to the left of that line. So it's this region here, going all the way up here. It's that region there that is our region. And we need to look at these inequalities. So the first one is x is greater than 1. So if we put a ruler here, we know this is 1 here, where the x value there. X is greater than 1. Well, clearly all this region is in the x is greater than 1 area. So that's a good statement. That's a correct statement. Y is greater than 5, so we can put the same ruler across here like that. Greater than 5. Well, clearly in this bit it does work, but below that it doesn't. So that is not true. And finally, the more tricky one is to do with x plus y times x minus y is greater than 24. Now, it looks like they've got these by multiplying the left-hand side of the inequalities together and multiplying the right-hand sides together. But that doesn't necessarily or immediately mean anything to me. We need to just try and find a point in the zone that does that doesn't satisfy this. We're just trying to find one point that doesn't satisfy this. If we can't find that point, then we need to consider the fact it might also be true if we can't find a point. So what do we need? And it needs to satisfy these regions. So if it's going to be greater than minus 24, we need something that's in here that will give us a sum that's greater than 6, but a difference that's greater than minus 4 as well. So x plus y I'm thinking along the lines of something, certainly the difference is going to be less than, sorry, it's greater than -4. But I want a negative number because I want something that's probably going to end up negative. So x plus y, I'm going to try and choose something along the lines of 8 and 10, because I know I want a big value, relatively large value for x, and then it's got to be such that y is bigger than x, because I want this to be negative. So what I'm saying now is if I choose 8 and 10, so let's write this here, x equals 8, y equals 10. Then when I add those together, I get x plus y is 18. So that's certainly bigger than 6. And x minus y equals, well, 8 minus 10 is -2. And that is certainly bigger than -4. When I multiply these together, I'm going to get a difference of 18 times -2 equals -36, and -36 is not bigger than -24. So this one, I found an example of where this is not inside the region. So that's not true either. That gives us the only one, which is the initial one. X is larger than 1. So 1 only is the one we want, which is B. So that's the answer that we need.